Hey guys, and welcome to the guide to naming your organic compounds. We're going to walk through two separate examples. Now, the first of which, we're going to deal with a branched alkane. We're going to have four steps in naming this. The first step being finding and circling the parent chain. The parent chain is the longest chain of carbons that you can trace with your finger uninterrupted without touching a carbon twice. Now, with this molecule that you're looking at, the parent chain is 4 carbons long. This is the longest chain that we can trace in this molecule without doubling back or touching a carbon twice. Now the parent chain's name is butane. It's butane because but is the prefix for 4 and ane because it's an alkane. All of the molecules that we're going to name are going to end with the ending A and E. So step 2, now that we know what the parent chain is to find the number of and type of substituents that are hanging off of the parent chain. So in this case, we only have one thing that we haven't circled yet, and that is our Br. So the Br is going to be our substituent. A Br group is called a bromo group. Now step 3, we know our parent and we know our substituent. Step 3 is to decide where on the chain our substituent is hanging off of. So we need to number the parent chain to give our substituent the lowest position number that we can give it. We can start numbering at either side of the chain. Now numbering left to right, we're going to go 1, 2, 3, 4. Now the 3 is where the bromo is hanging off. Now if we number from right to left, we're going to go 1, 2, 3, 4. Now if we back up a bit, our bromo is hanging off of the second position here. So comparing the two numbering schemes, we could either put the bromo on the second position or the third position. We're going to pick second position because that gives us the lowest number that we can possibly have for Br. So step 4 is to put it all together. Now our parent name was butane, and the group that's hanging off of that butane is a bromo group. And where is it hanging off? The second position. Notice the number and the letter in the name are separated by a dash. Whenever you have a number followed by a letter, the dash needs to separate the two of them. But otherwise, there are no spaces in the name. It's all just one long chain of a name. 2-bromobutane. And backing up, our parent chain, what hangs off, and where it's hanging off of all provide what you would consider a street address for how to name this organic compound. What it is, what hangs off, and where to find it. Now example 2 is similar, but we're going to deal with a cycloalkane now. Now step 1 we said was to find the parent chain, the longest chain of carbons that we can find uninterrupted without touching a carbon twice. Now in this case it might look like we could have a hexane parent chain, because I can trace 6 carbons, but in a cyclic alkane, you want to just pick the ring. Cycloalkanes have a special rule where we just pick the ring to be the parent chain. So with 4 carbons, this ring we're going to use a cyclo prefix for because it does form a ring. It's not a straight chain alkane. So our parent is going to be called cyclobutane. Cyclo for the ring, but for 4 carbons, and ane because that's what we end all of these alkanes with. Now step 2, find the number and type of substituents. If the ring is our parent, then our substituents are these 2 methyl groups that are up top. Now I call them methyl groups because each of them only has 1 carbon, and our prefix for 1 carbon is meth. Now, if we have 2 1-carbon groups, we're going to call this dimethyl because we have 2 methyl groups. Di stands for 2, methyl stands for our 1-carbon group. So we have our parent chain and we have our substituents hanging off. Now we need to decide where those substituents go. So on a ring, it's always a good rule of thumb to start numbering where you have something hanging off on the ring. So I'm going to start with a 1 here. And a 2, we're going to move clockwise all the way to 4. This leaves my position numbers at 1 and 2. Now let's try out another possibility. I'm going to number counterclockwise. Either way we look at this, my position numbers for my methyl groups are going to be 1 and 2. So it doesn't matter which way we go with this one. Now putting it all together at the end here, our parent chain was cyclobutane. Cyclo because we had a ring, bute for 4 carbons in that ring, and ane because we have an alkane. Dimethyl says we have 2 methyl groups hanging off of this ring. So we need to know where they're hanging off, the 1 and 2 position. This is the complete name. Notice the numbers are separated by commas, and the numbers and the letters are separated by a dash. So breaking it apart one more time, we've got cyclo meaning the ring, bute meaning 4 carbons, giving us a parent chain of cyclobutane. What's hanging off? 2 methyl groups, so we say dimethyl. And the positions are 1 and 2 on the ring where we're going to find those methyl groups. So thanks for watching, guys. Make sure you check out the handout that goes along with these.